Welcome to the next class. What we're going to do today is we're going to start talking about the way in which you can develop Android applications to access persistent data. And first we're going to talk about the SQLite mechanism, which is one of the ways you can store data persistently in an Android environment. And then we're going to talk about content providers and content resolvers, which are ways of accessing that information in a more external manner by more than one application. So there's a number of different ways in Android to store data. We're going to talk primarily today about SQLite, but there's other ways to access data as well. There's files, which you've been doing already for various things. There's also shared preferences, which is another way to do things. And we'll talk about those probably by the end of the class. By the time the class is done, we'll cover all that stuff. So what I want to do first is talk a bit about SQLite, and I'm going to describe what SQLite is and talk about ways in which you can program to it in Android. As a general rule of thumb, you rarely access it directly, although it's certainly possible to do so, but you almost always access it via the content provider, content resolver APIs, and we'll talk about those next. So SQLite is essentially a so-called in-memory database, and what that means is it's accessed in the context of your phone. It's not going off to some server somewhere, some off board. It's accessed on the phone itself, and it's also described and formulated in a so-called relational way. So you have tables, and these tables have rows, and they have columns, and you can do various queries on them and things like that. It's designed to try to take up a relatively small amount of space, around 350 kilobytes, but it still attempts to provide the bulk of the kinds of features that you'd expect to find in SQL92, which is a standard for data access. It's typically used for systems that require the so-called ACID properties, which is atomic, consistent, isolated, and durable. And what that basically means is if something goes wrong, there's a way to roll back to things that had been done before. And there's also a lot of support for being able to do queries and other kinds of operations. In fact, it supports something called the CRUD, create, read, and update and write operations, and delete operations, where query is kind of like read. So it's CRUD. We'll talk more about that when we talk about content providers. Typically, when you access the database, it will end up involving the file system in one way or another. And for that reason, it could potentially be relatively slow, relatively being a relative term, of course. So as a result, it's typically advisable not to access the data directly from an application using a synchronous call, using query, although you can certainly do query, but you would typically not want to have your main application thread doing a query. You'd want to do something else. You'd either want to have your main application thread running in an async task and accessing it in a separate thread of control, a background thread, so it can block without blocking the main thread of control. Or more commonly and more modern ways of handling this in Android are to do something that involves the use of content loaders and/or asynchronous query handlers, which are two other ways of trying to be able to have operations run in background and then be able to have the results come back to you when you're done. And they have different pros and cons and different trade-offs. And we'll talk more about those things. Those things are going to be very important for you to understand in order to do your programming assignment. So there's a number of classes that are conventionally used with SQLite in order to be able to program it. One of them, which is sort of the workhorse class, is SQLite Database. And this is basically a class that gives you the core operations like insert, update, delete, and so on. These are some of the things you can do with the SQLite database class. It also provides a way of being able to execute SQL directly. So you can create an SQL statement, a raw SQL statement, by creating strings and appending and concatenating the strings and so on, or prepending things into the strings. So that's one way to go ahead and access this. And then you can also go ahead and execute various queries. And so you can make queries by either raw queries or by query methods that are created somehow, often by something called a query builder. And you'll see some examples of the query builder later. A query builder is basically a factory or a builder pattern that allows you to build up a complex query piece at a time, and when you're all done, you can go ahead and say, run the query, and it'll go ahead and execute and perform the query. The typical way that you interact with the insert and Update operations is by using something called content values. And content values are basically key value pairs that can be used to reference the column identifier, which is what the key is, and then the value, which is the value of that column identifier. So if you had a database of artists, then the key might be the artist's name, and the value might be something about the artist. And you can use these typically for the insert and update operations that are available on SQLite databases. Now, there's some other things that you also have as well, and you can program these things in different ways with different degrees of complexity that you get to choose based on how you want to access the information. So one thing that they provide is kind of a utility class or a helper class is something called SQLite Open Helper. And it has some constructors and some other operations in it that help to shield the complexities of programming to the SQLite database class itself. So it's kind of a wrapper or a proxy or a facade, if you will, around the other class. And so the onCreate method is typically something that you would override, and then you would go ahead and figure out how to create the SQL table. And this will be called the first time this thing is invoked. So the first time that you go ahead and make one of these things, this is the method that's called back for you to go ahead and initialize the values in the database. There's also something called onUpgrade, which is a hook method that you can fill in if you want to be able to upgrade your database, if you want to be able to change the schema over time for different versions. It's instructive to take a look at various parts of Android, because this kind of capability gets used a lot in some parts of Android. And you'll find all kinds of interesting evolutions that have taken place over time, sometimes by the Android open source people, sometimes by their partners who add all kinds of enhancements and extensions to the core schemas for various things like contacts or SMS or MMS messages or calendar events. All kinds of things that you might store persistently can be enhanced and evolved, and being able to upgrade the schema is really important to do that. The other thing that you typically do with the SQLite Open Helper is be able to get access to the underlying database in various modes. And the typical two modes are read mode, where, as you might expect, you can only read the contents or query the contents of the database, and write mode, where you can both insert and delete and update the values of the database. And obviously the right choice depends on what it is you're trying to do. If you have read-only data, then you'd want to get read access. If you have the need to write to the database and you're in a position to do that properly, because that's something that you're allowed to do, then you want to be able to have these other capabilities to write as well as to read, of course. So here's a very simple example just to kind of illustrate how all these things fit together. And so basically what we're going to do here is we're going to define an artist database helper class, which extends SQLite Open Helper, so it kind of inherits from it and then uses some of the hooks that it provides. As you can see here, if you take a look, we have a string that we define, which is called create command, and this is used to essentially create an SQL table. It's SQL command to create a table of artists. And if you read this thing, you can basically see that the artists table has an ID field, and that's going to be incremented automatically. It has, and that you can see ID is an integer, it's the primary key, and it auto increments itself. So it'll keep track of the number, unambiguously keep track of a monotonically increasing set of fields that it uses in order to keep track of the artist ID. And then we also have a name, and as you can see, the name is text, and the name can't be null. So down here we have the constructor. As you can see, the constructor calls up to the superclass and gives a name to the table, so it's going to call it the artist DB or artist database. The onCreate call goes ahead and says, hey database, please execute this command. And this command is the one that creates the table. So at that point the table will be created if it hadn't already been called before. And then the onUpgrade hook method, which we don't really show here, is the place where we would put all the logic to handle upgrades. We might have a different version that would have a different set of fields. Besides the artist's name, we might add other things like number of hit records or whatever they might want to have. It's common, although not required, to have a subclass of SQL open helper for every table in your system. That's a pretty typical way of doing things. For every table you have a subclass of SQLite open helper. But you're not required to do that, just a convention that's easy to do. So let's take a look and see how we might actually use this particular helper class that we defined in the context of an activity. So as you see here, we're going to have an activity called database example activity that extends list activity. And we're going to go ahead and define some columns. So we're going to have underscore ID and name. And those things we're going to use a little later when we do some of the operations here. And then we have our SQLite database down here. And here's the onCreate method that we defined for our activity. As you can see, we go ahead and create our new artist database helper, passing in the context from the applications activity. We go ahead and get a writable database, and then we do some operations. We insert some artists. We delete Lady Gaga, just picking on her again. And then we go ahead and get a cursor back from all the artists that we have in our database, and we display all the artists that we have there. And we'll talk about some of those things later. I'll talk about just some of the operations here. So those are basically the key steps that you do. So we make the subclass instance of SQLite open helper, create the database, do some stuff. It's also common, although again not required, to put your SQLite database in some kind of singleton in order to be able to make it easier to access it in concurrent environment, or to access it in an environment where you've got to manage the memory and so on. So that's, again, not an uncommon thing to do, but it's not required by any means. So before we show some examples, let's talk a little bit more about some of the operations that are defined on an SQLite database. These are some of the things that you can do on it. One of the things you can do, of course, makes sense, is insert something. That's the create part. That's the C part in the CRUD operations. So you're creating something, you're inserting something into the database. As you can see here, you give it the name of the table that you want to put something into, and then you give it this thing called the content values, and that's what's going to get stuck into the appropriate place in the table. And we'll take a look at that in more detail, but as you'll see that the keys are column names in the table, and we go ahead and insert things one entry at a time. Here's a little example of a user interface that might be used for this kind of stuff. So as you can see here, we've got some kind of application where we've got some operations, the add, show, update, and delete operations, roughly corresponding to the CRUD calls. And when you click on add, it goes ahead and queries you to add in a new member. It's kind of like using your contacts or people app on your Android phone to add new entries into the contacts database. And that would go ahead and do an insert operation into the SQLite database. And you can read more about this operation here and what the values mean. Here's an example of how we might do this. Here's the insert artists method. As you can see, we create a new content values object, and then we go ahead and we stick a bunch of things into it. So we're going to put in the name, because remember that's the column that we have here. And we're going to put in Lady Gaga. We're going to go ahead and put in Johnny Cash, put in a bunch of different kinds of things. We'll put Sting in there just to give a wide, diverse range of different artists from different genres over different times. And so now we have those entries that are part of the database. Later, of course, we can query for things and get those results back, and we can go and update them and stuff. Something else we can do if we get tired of some of the entries in our database is we can go ahead and remove them. We can delete them out of the database. And in this particular case, once again, you give it a table, the name of the table you want to manipulate, and then you give it a where clause. And it basically is a way to match against the columns, the keys that you pass in when you inserted the values. And you give it a particular value, and it'll go ahead and match all the things that correspond to that, and it will remove them from the table. And so if you have some options here. You can either pass in some of these things, or you can pass in a null value, and that says just delete everything. Maybe a little bit draconian, but if there's situations where you want to get rid of a table's contents altogether, you can just pass in null. So here's an example of how we might use this. Going back to our example before, you might have a delete method that you would have defined on your interface, and when you do delete, you'll end up getting a list of the members that are in your database, and you can go ahead and either edit them or delete them and so on. Obviously, if you do edit, then you would be doing an update. If you do delete, it'll go ahead and remove the entry and take the particular row or rows out of the underlying SQLite database. So here's an example of how we might do this. We're going to delete Lady Gaga, and what we're going to do is we're going to say, I want you to go to the artist database here, and I want you to find anything that has the name. Oops, I think this got a little bit too funky. You go ahead and say, I want to find anybody, I want to delete a row who has the column value name as the key. And what we're going to do here is we're going to look for anybody whose name is Lady Gaga. And the way this works is as follows. So you can see here we're going to basically append to the name equals question mark. And question mark is essentially a placeholder, and that gets replaced with whatever we pass in here. So in this particular case, we're going to pass in Lady Gaga, and this is basically the use of the where args. So we can come along and delete these kinds of things. So after that operation runs, then Lady Gaga is no longer a row in the database, and that entry is now available to store something else when it's appropriate. So that's basically how you put stuff into a table, how you take stuff out to the table. Not surprisingly, update is more or less the same thing as putting an insert in, except the expectation is it's already there, so you're updating what's there. But the main workhorse thing, and this is what you do the bulk of the time, once you build up your database, once you build up your SQLite object or tables, you go ahead and query it. And so this is kind of the read part of the CRUD operations. So query basically allows you to access the values. And there's a lot of different ways to do this, and there's lots of potential complexity. Android provides a bunch of helper classes that try to winnow down and reduce the complexity to some extent. But there's a lot more moving parts here that you have to be aware of, because it's very powerful. It's giving you access to the bulk of the SQL 92 query semantics and operations. So there's a couple different ways to do it. One way to do it is to call raw query. In this case, you basically pass in an SQL string, and you are responsible for putting that string together. You're responsible for concatenating or prepending or appending or whatever the various elements in the string. You're responsible for making sure the string is syntactically correct, and you go ahead and pass it in. You can also have these things called selection args, where if you include the question mark placeholders in the original string, the SQL string, then the selection args are the values that you want to have replaced for those placeholders. Does anybody know why placeholders are a useful thing? What's the benefit of having a placeholder? Austin?
You can sanitize your input against SQL injection.
You could protect your input against SQL injection. That would be one thing. That's a common vulnerability. Jonathan?
Yeah, same thing. You don't have to pay the overhead of string concatenation at runtime.
Right. So basically, you can make the arguments parameters that could be set a variety of different ways. You could have them come in from user input, or you could read them out of a config file, or whatever you want to do. And that way you don't have to change all the other stuff. You just have to change the parameters as opposed to having to change the underlying string and rebuild it. So it just gets it a little bit cleaner, a little bit faster, a little bit more secure, because you can protect against some of the common ways of doing things, where someone could type in, delete the table or whatever, and you delete things that were not expected to be deleted. What you get back, by the way, from the query operations is something called a cursor, and we'll talk about a cursor later. A cursor is essentially a variant of the iterator pattern that gives you an interface that you can use to access the elements that matched what the query returned. And so it's a way of kind of abstracting you from the details of how you get those elements a chunk at a time or one at a time. So cursors are not synchronized. You have to be careful if you're using multi-threaded processing. You can also use query. So there's raw query and there's query. And as you can see, query, raw query is pretty straightforward. It just takes a string and the selection args as a second parameter. Query is got a lot more stuff going on here. You pass in the table that you want to be querying against, and then you pass in things like the columns, which basically will let it go ahead and select out of a database that may have many columns. You can pull out just the ones that you're interested in. And you can also have a selection, which is a way to filter the data in various ways so you don't get all of the data. And you can have selection arg, so you can filter out things using the replacement we were just talking about. You can also group rows. You can have filters applied to the groups, and then you can also determine how you want the output to be ordered. And I think there's even some options that aren't shown here, but there's many other query parameters where you can limit the number of things that come back from query. So you don't get back the entire world, you just get back the first 50. That's why ordering is important, because oftentimes you want to order stuff so you get back things in an order that matters. For example, with one place this kind of stuff is used commonly is in looking up, movies, searching for movies, or searching for books on your phone, or searching for recent entries when you go look up in Google Maps to see directions, and so on and so forth. And oftentimes the underlying system wants to order stuff in some smart way so you get the data back in a manner that's most useful to you. For example, if you're looking up people's names, let's say you start typing into the People Finder Steve, and you may have lots of friends named Steve or Chris or whatever. And so what it will do is it'll take a look at a variety of different properties. It might take a look at, who of the people have you looked at most recently, or who have you sent email to recently, or whatever. And it would take a bunch of things into account, and then it would try to return to you the list of contacts that match the keyword search in a way that would be most useful to you by returning the ones earlier. They're the ones you've talked to most recently, or interacted with, or looked up most recently, or whatever. So you can make the systems kind of arbitrarily smart based on fields. Likewise, you might do something if you're keeping track of Google Maps searches, or looking up movies or books in some kind of Play Store-like interface. It might keep track as one of the fields of the last time something was accessed. And so it might return to you the things sorted in descending time order. So the most recent stuff shows up first. So those are examples of how you can describe what the order by clause is. And that can be basically something that matches. It can have various kinds of conditional expressions in it. It's very powerful. And under the hood, SQLite is doing all the details to keep track of this stuff, so it makes your life easier as a programmer once you learn how to use those interfaces, of course. So here's a couple simple examples using our artist database. The first one we're going to look at is using the raw SQL, where we're basically just going out and doing a raw query. We're saying, select on ID and name from the artist database, and that'll just dump back everything in there that corresponds to what's in the database. So that's basically just giving back all the contents. Here's a use of query to do the same thing. As you can see here, actually, I think the raw SQL is actually a little easier to understand in some ways because it's more direct. But here you say, go look at this table, the artist table, and here are the columns I want you to go pull out for me. So here you're selecting from these two columns. You hard code them in that name. Here you're giving them as parameters. I hard code them, but you could make them parameters, of course, too. And then everything else is null, because you don't care about ordering, you don't care about filtering, you don't care about groups, and other kinds of things that you can do with query. You're just saying null, 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 null. This is, by the way, would be one of those situations where it would be nice if Java supported default parameters to method calls, because it gets kind of ugly after a while. You can get much, much more sophisticated, much, much more complicated than what I'm showing you here. That's just a simple example. What query returns to you is this thing called a cursor, which is basically an iterator that allows you to go and look through all the elements one at a time. Under the hood, it can buffer, it can do all kinds of clever things. When you start seeing cursor loaders, which you'll look at in this current assignment, you'll get a chance to program against this stuff. And a lot of these things are hidden from you. You can give it hints in some cases to do a more effective job of buffering the results, so it doesn't use too much memory, yet it is still responsive. The main idea behind a cursor is to avoid having to either give you back things one at a time, or pulling them from the database one at a time, which could be very slow, versus grabbing them all at once, which could be very large. And so cursor hides that from you, and it can then do intelligent buffering under the hood in order to be able to make that as clean and efficient as can be the case based on the abstraction. Cursors give you a couple of helper methods to give you information that's useful about the cursor. You can find out how many items there are in the query, so that may give you a sense of what you're looking at, the scope. You can also move around. You can go to the beginning of the query, beginning of the cursor. You can move, sort of iteratively through it, one element at a time, between the various rows that have come back as part of the query. You can also check to see if you're done, to the end of this thing. And then you've also got a number of get methods that are strongly typed that you can use to extract things out. And you can basically access column data for the current position to extract things out from the row that corresponds to each element in the cursor. So you can go in there and kind of pick and choose the various columns, the various fields that you really are interested in. And we'll see some examples of that. You'll get a chance to program that kind of stuff. We'll look at some examples when we look at more details of how to program this. You get a get column index. There's another thing you can do to index into the column, or it'll throw an exception if you give the wrong index. And keep in mind that cursors are, they're not infinite. They're a resource that has to be managed, so you have to remember to close them. I think that they've added some helper stuff to later parts of Android that will close these things automatically, because that was a common bug people had where they would forget to close the cursor and they'd be leaking resources and it couldn't be freed up and so on. So I think there's actually some other cursors that are a little bit cleaner about cleaning themselves up when they're not being used. Here's a very, very simple example. If you take a look at the, you really can't see the thing very closely, but if you put a bunch of artists into a database and then you went ahead and did this, this is how you could do it. So in this particular case, this is a display artists method where we take the cursor that was given back to us by the query call, and we go ahead and essentially create something called a simple cursor adapter, which is going to be put into a list adapter, and we tell it to go ahead and extract out the name and ID field, giving in the various values that we need here, and that'll go ahead and look up, find the stuff in the database, take the stuff in the cursor that we've got, and it'll go ahead and display it to the screen as we're showing here. So that's just a simple way to display the results of doing a query. And there's lots and lots and lots more stuff that's going on there. Once you've built up these SQLite databases in the phone, you can either access them programmatically, like I just showed there, to go ahead and take a look and dump the values by making these query calls and iterating through the results. You can also use some lower level tools. So there's various tools that are used. And so when you create something, when you create a table, it actually stores it in a well-defined location in the Android file system. And if you take a look here, it sort of tells you what it does. And the capital letters are things that are filled in, or placeholders for things that are filled in by stuff that you provide or the system provides on your behalf. So data is the path that your environment get data directory method returns. Typically it's data, so you have data/data/data. App name is your application name, your fully qualified application name, and then the file name is the name that you gave for your particular database, like ArtistDB or whatever. Here's a simple example of how you can access this, assuming you've got your ADB shell up and running and you've got your phone attached. You can go ahead and look at the contents of what's in the databases via this SQLite 3 helper command. So here's a case where we're going to go ahead and look at some information about the launch database, and we go ahead and connect to it via SQLite 3, and then we can ask it various things. We can ask it to give us the tables that it supplies. It has Android metadata and favorites. We can go look at the favorites, and it gives us some stuff there. It gives you basically the schemas, and so on and so forth, and other information. So you can use this in order to programmatically, or you can, not programmatically, declaratively, through command line operations, see what's actually in the databases and manipulate them in various ways without having to write a program to do it. It's a utility to access that stuff. Okay, any questions about that? So that's a quick overview of SQLite. What I'd like to do now is switch over to the next topic, which are content providers. And as we'll see here, content providers are basically a way of being able to take various kinds of data stored in various kinds of ways, SQLite being by far the most common, and making that data accessible to other applications besides just one application. SQLite works for applications that need access to private data. What content providers do is they make it possible to share that data among other applications and access it in other ways, and also allow you to be able to access it across address space boundaries and so on and so forth. So they give us a way to manage access to a central repository of data that's structured and make that accessible to other things on the phone. They also give you some ways of being able to have permissions and protection to try to give a little better security to accessing the data so that not everybody can get it. If you have data that's running or data that's residing in one process and you want to get to it from applications running in a different process, then content providers and the content resolvers used to access them are crucial to being able to do that. They support the CRUD, create, read, update, and delete operations, which are essentially just proxies or pass-throughs for things that go down and access the real database operations. A content provider doesn't really store data. It provides a means to access stored data, if that makes any sense. And typically applications go ahead and access the content providers. And content providers are one of the kinds of components in Android that can actually be put into a manifest file. So if you want to expose information, you can do it through a content provider. There are lots and lots of content providers on Android. Pretty much all the interesting applications have them. The browser uses a content provider to keep track of browsing history and bookmarks. You have telephone usage for call logs, obviously persistent. Contact data in the People Finder app keeps track of your contacts. Calendar, MMS, SMS, it's used to store. It's used to access messages that are sent and received. It doesn't store it, but it is used to access the underlying SQLite database that stores and receives that stuff. There's dictionary things that are used. The YouTube app that is used to keep track of your videos that you're watching, and many, many, many more. There's all kinds of stuff. Pretty much everything that's interesting. Maps application, Play Store, the launcher has providers. Most of the time, they are located in the Android source code under packages/providers. That's the most common place you'll find them. But they're also sometimes found other places. For example, in Android, for whatever reason, Packages Apps Browser has the providers directory under the Packages Apps Browser part, as opposed to being in the providers part. I don't know why, but that's just the way it evolved historically. And there are various things you can do. You can actually go on the phone in many phones, and you can click and indicate whether you want to make those providers searchable, whether or not you should be able to look them up when you use the universal search box mechanism that Android provides. Many phones, not all phones, but many versions of Android make it possible to go ahead and search all the content on your phone, as well as be able to search content on the web as well. And they can unify all that stuff together through the quick search box, QSB. The content provider typically presents data to apps in terms of these tables. Usually under the hood, those are done with SQLite. And it uses all the good stuff we talked about before, SQLite-like operations. As with SQLite, the abstraction exposed to the user is this one of a row, which contains the fields, which are described by columns. So each column in a row represents an individual piece of data for an instance of that particular piece of data. So for example, if you looked at the user dictionary application, you might see something where you keep track of certain words and the applications that are using them and the frequency in which they are being used, other information like whether they're accessed using English or French or Swahili or whatever they want to use. And that information can be stored and then used for various purposes. The typical things that we would think about being used, of course, would be stuff like history lists or recently searched locations in Google Maps, or the call log where you made calls, so you can go back and click and find those callers again, and so on and so forth. Lots of different uses for stuff like this. The content provider, so we always joke and say that no problem in computer science is so hard it can't be solved with enough levels of indirection, right? If you have enough levels of indirection, you can solve anything. So that's essentially what's going on with content providers. Content providers provide a level of indirection on the way in which the actual data is stored. But content providers themselves are accessed via yet another level of indirection, which is the content resolver. So you never access the content provider directly. You always access it indirectly through a content resolver. And there's a variety of different means or reasons for this. And there are also certain workarounds in order to be able to optimize the use of stuff, because there's some extra overhead that comes from this. And we'll talk about that later. So the content providers basically provide you with a proxy, if you will, to the underlying content content resolvers provide you with a proxy to the content providers. And one of the consequences of doing that is it makes it possible to have multiple applications accessing the same content provider through different content resolver proxies. There are also some other things you can do because of this abstraction. One of the cool ones that we'll talk about and you'll see is this ability to have notifications take place. So you can actually have applications that subscribe to be told when data changes in the content provider. So when something gets modified in the content provider, you can automatically be notified, which is important, so you don't have to have applications repeatedly querying the content provider saying, has something changed, has something changed, has something changed? Not surprisingly, that's another good example of the publisher-subscriber pattern, or the observer pattern that we talked about last time. So there's a bunch of uses of observer in Android, one of which is these content resolver change notification mechanisms, others of which are the broadcast receiver stuff. So there's many known uses. And typically the way that you access this stuff is you go ahead and use a factory method called getContentResolver. You invoke that, and it gives you back the appropriate content resolver, and then you can use that to access what you need. So again, just to reiterate this point, you don't access the content providers directly. You go through a content resolver, and typically what happens is you make a call to the result of getContentResolver, and you query that, and that call goes to content resolver query, not content provider query. And what this method does is it takes a look at what you passed it when you query, and it goes ahead and it figures out which content provider is actually being referenced by the query call. Now, that particular set of steps adds some overhead, and so there's ways to optimize this that we'll talk about later. But out of the box, that's what happens. You call query on content resolver, and it does some things based on the URI, and then it figures out which content provider it wants to forward the request to. And finally, after a couple levels of checks and these lookups that take place and permission checks and so on, it goes ahead and calls down to the content provider, which will either return to you the results of your request, or it'll throw an exception and say, sorry, what you asked for didn't really turn out to be possible for whatever reason. You tried to delete something that wasn't there, for example. Now, the whole thing hangs together with something called content URIs, which are a little bit like a URI that you would use to access information in the internet, with the primary difference being that the content is always resolvable locally on the device rather than going off board and making a call across the network. So anytime something is prefixed with content, colon // that means it's going to be looked up in the Android content provider content resolver framework model rather than going off board. So if you take a look and kind of break down what you pass in for a content URI, or what you use to describe a content URI, it has a couple of different parts. It has the sort of the prefix, which says this is a content URI thing managed by the content provider system. This thing called the authority, which is the ID for the particular content provider, which is usually going to indicate whether it's for YouTube, or whether it's for browser, or whether it's for calendar, or MMS, SMS, whatever. It says the particular content provider identity, if you will. The path, which is basically kind of like a path name, sort of nested hierarchy of steps. And then that finally culminates at the very end with the specific ID of the resource you're trying to access. So that's kind of like a file at the end of a path name. Or if you type out a URL, it's kind of like blobbity blobbity blop dot or index.html, where that provides you with the final piece of the puzzle. Now, keep in mind that content providers, like content resolvers, are themselves proxies or facades. They aren't really doing the work themselves. They are sort of middle-level managers that shuffle the work around to be done by the actual worker bees that know how to store and retrieve data and run queries persistently. And there's a bunch of different ways you can do this. A common way is through SQLite, because that's easy, it's powerful, it kind of comes pre-baked. Once you understand SQL, it's not hard to program. It can get a little tedious, but if you need to do something that requires SQL-like stuff, writing it any other way is going to be even more tedious, probably. But you can also store other things. You can store them in normal files. They can be in regular, good old Android files, text files, binary files. You can store stuff in XML. You could, in fact, even write some kind of service that would sit there and forward these requests to be resolved remotely in some other system. So you could build sort of a bridge or a router or a mediator or whatever you want to call it that sits between your client activity and some remote server, and you could pass it things to work on, and it would go ahead and forward them on to get the job done. Here are some of the operations you can do with content providers. And keep in mind, these look an awful lot like what the underlying SQLite database operations look like. So you have this thing called insert, where you give it the URI. And that's not the URL, that's the URI. And you give it a set of content values, and that goes ahead and inserts this thing into the table at the given URI. There we go. And so that, if you're going to implement this using the underlying SQLite mechanisms, it's pretty much just grab the content values that come in and throw it into the underlying database. Pretty straightforward. And it returns to you the URI of the newly created row. I don't know why I keep saying URL. That's probably left over from previous versions. And then you can use that in various ways. You can use that information. For example, you could use that if you were inserting a file, then you would know, sort of where it was put into the underlying system, which could be useful for other kinds of things. Likewise, you can also delete stuff using the delete operation, which again looks very, very much like what we had before. It's got URIs. You pass in the URI, and you pass in the where clause and the selection args, and so on and so forth. And when this thing returns, after it deletes whatever you asked it to delete, it'll tell you what it deleted. So you may have deleted multiple things, you may have deleted one thing, you may have deleted nothing at all because what you asked for didn't match. There's also some other stuff you can do which is more powerful, and it's a little bit complicated to learn how to use this, but it actually is used extensively throughout Android for various things. There's actually a way of being able to create a bunch of insert and or delete operations, stick them into an array list of insert and delete operations, and then have them all run in one fell swoop. So you can basically use this so-called apply batch operation, which just basically prevents you from having to make many, many calls to insert and remove. You can pile them all up into one list and then call apply batch, and all those things get applied sort of simultaneously, or at least in theory they're simultaneously. They're simultaneously from the point of view you don't have to do each one of them individually. And so that's kind of a latency hiding technique. You're passing this thing over. It can perhaps be optimized in various ways. There's also a query operation, which is not unlike the query operation SQLite provides. And as before, it gives you back a cursor, and then you can do various things to the cursor. If you take a look at the stuff that's provided here, again, it looks very, very much like what's defined in SQLite and SQL. It's got the URI. It's got this projection, which are the columns that you want to pay attention to. It's got the selection, which tells you when to select the values when columns have a certain value. So it only takes a subset, potentially a subset of the results, because it's filtering these kinds of things. And once again, you can give it the sort order command, which we use to determine the way in which the cursor returns the matching queries back to you in some kind of order. So to summarize this particular discussion, the SQLite database is private to the app that creates it. So that works fine, but oftentimes we're trying to define services or providers of some kind, and we would like to be able to make them accessible to more than one app, or make it accessible in a more common, more conventional way, a way we can script with the Android manifest files and so on. So content providers give you the ability to do that. The content providers allow the apps to access the data. It's usually stored in SQLite. And you can use this in all kinds of ways. You don't have to share the data with other apps if you don't want to. It just makes it possible to do that. The app data is private by default. So if you want to be able to share this, you use a content provider, and then you make sure that you describe the content provider using the provider element tag in the manifest file. And that announces to the outside world that there's a content provider, and then other parts of the system can access that and go ahead and make operation calls to insert, delete, query, and so on, update, assuming that they have the appropriate permissions to do so. Okay.